The URLs for the recording and the slides that are being presented today will be at the bottom of your webinar invitation, and we'll mount them within a day or so to the sites. If you have any questions, please post them in the chat. Some may be answered during the presentation, and some of the questions may be held until at the end of the presentation. I see from the participants list, almost 100, that almost everybody is muted. For those that haven't, please mute. And if we have time at the end of the chat, we may allow questions to be provided directly. To help conserve the bandwidth, please do not project your video. I see that most people have not, just a few, and we can correct that. To introduce you again to Kirk Williams, he has presented before in this webinar series. Kirk is the chief of the mechanical section for the Fort Worth district, and he's been there for a bit over a dozen years. He has focused his expertise on sustainable design, development, commissioning, energy modeling, and life cycle cost analysis, which befits his position as the chief of the mechanical section. He has also worked on a number of buildings himself. He has a degree in mechanical engineering from Texas Tech and is a registered professional engineer in Texas, certified energy manager, and certified building commissioning professional. If you hadn't suspected, he was born, raised, and currently resides in Texas, near where he works in Fort Worth. And with that, I'll turn it over to Kirk for the presentation.
Okay, great. Thanks, Ned. Just a quick sound check. Y'all hear me okay?
Coming through on my end, Kirk. Thank you.
Okay, great. Good deal. Okay, so thanks for joining us this week for life cycle cost analysis. It should be a good one. So we'll jump right in here. So objective from this presentation, similar to a lot of the other sustainability webinars, is we're going to summarize strategies to comply with the Army's requirements to perform life cycle cost analysis. So hope for better understanding for the participants of the LCCA requirements, policy guidance, and that directs the content and creation of what goes into our life cycle cost analysis. Okay, so similar resources page to what we've had in the other webinars. Several great resources here. First one being the Sustainability UFC. The next one is an engineering regulation for energy modeling and life cycle cost analysis. Below that is the ECB for execution of life cycle cost analysis. Then we have the USACE team site for the sustainability. Like Ned said, that's where the slides and recording are going to end up after this. Additionally, we have the IGCC citation here. This is the criteria formerly known as ASHRAE 189. And then we also have Lead Online. So real quick, we're going to hone in on this presentation primarily on the UFC, the ER, and the ECB. Not listed on this slide is the ASA SDD policy and SIM note number 22, which will also be discussed kind of throughout. So, okay, so the intent of this presentation is to give a high-level presentation on life cycle cost analysis. The objective is to inform about compliance with the Army's LCCA policy. So with that, we're going to discuss what is an LCCA, current policy as it stands, some common tools for performing LCCAs, and try to give a real kind of high-level overview of some real LCCAs. So I've been teaching the subject for quite a while through the sustainability, especially in the prospect course, and it's kind of interesting to see how the LCCA role has changed quite a bit in the last couple of years. In teaching it, the topic used to kind of feel like a speed bump in a parking lot, something that people tried to avoid or stay awake during. So it's kind of interesting to see how it's gone from that to taking center stage in the last couple of years through some of the different criteria, particularly the SIM note number 22 and the ECB. So it's kind of gotten pulled to the forefront from being a topic that was usually not real highlighted for a lot of people. So just a real brief kind of what we're not going to discuss with the presentation. Not going to go into a forum on, why the policy exists, why the analysis is placed at the project level rather than programmatic level. Not going to get into detailed technical features that can be studied. Refer you to Huntsville and several industry kind of references for things like that. And then opinions about the policy. So everyone has an opinion. Your energy is going to be better directed towards headquarters or beyond. My sphere of influence here is really taking the policy that's provided and trying to give kind of highlights and recommendations from that. So in summary, going to focus on compliance rather than complaints. Just kind of want to start that one out there. You'll see with the LCCAs, there can be a lot of work with it, and there's been several complaints. So, but I'm going to focus on compliance for this presentation. So I'm going to jump in with what is an LCCA. You go to your technical team and you ask them, hey, tell me what an LCCA is. You get an explanation that might sound like the math problem from Good Will Hunting. It sounds really complex, and you kind of trying to get them to tell you in simple terms what they think is really complex. So that's kind of the picture. The bigger picture there is just kind of a joke on what people might think an LCCA is. And then if you ask for an example of an LCCA, you might think you're asking for a hair from a mythical creature like Bigfoot. A lot of people have seen one, but they've never confirmed if it was good, and then they're not going to share it with you. It's almost this, it's been seen, but it's not, held. And so just kind of a joke with that of, LCCAs can look a lot of different ways. I've seen several that are almost like a college dissertation, 100+ page appendices. I've also seen quite a few one-page LCCAs. I'll say a lot of those really short ones that I get are from AEs when I ask them, where are your LCCAs? And it's late in design, and then all of a sudden one magically appears. But the overall kind of the takeaway from this is what is the mythical LCCA and how do you capture it for your project? So getting serious, what is an LCCA? So put the definition on the slide here. This is from the CFR Title 10, Part 436, Federal Energy Management and Planning. So really what we're seeing here is an LCCA is an analysis to capture the overall total cost of the facility. This is the first cost that's supposed to capture construction, maintenance, operations of the facility, utility cost and repairs, salvage value, and the materials at the end of the useful life. So holistically, what is it going to cost to have this building? As you can imagine, that's a very difficult thing to simulate, and there's a lot of factors that go into it, especially when you're doing project planning, that go into estimating something for total ownership cost. It's kind of rolled up in there with like estimating the cost of owning a car. There's a lot of factors. One of the key ones that's going to really be important is who is driving. Who's working in the building. How are they operating the building? And then there's a lot of external things. As far as weather, maintenance, occupancy schedules. So there's a lot of things that can go. There's a lot of variables, but at the end of the day, it is possible to execute. It's just capturing an overall total cost of the facility is the intent of the goal. So jumping into kind of the policy, here. So we have our CFR, the law, and then we trickle down to our UFC, which is what a lot of our webinar series has been based around, the sustainability UFC. We can see that next to that, we have the ASA SDD policy. Not necessarily that it's going to rank in different order. However, just want to have that on the slide for reference here. And then we can see below that we get into the engineering regulation for energy modeling and LCCAs, as well as the ECB 2020-8. And then finally, there is the SIM note from General Simonite in 2019 that was directing USACE to perform LCCAs. My understanding is this was what led into the ECB 2020-8 being created. So a little bit of history there, as well as try to give an overview of our policy hierarchy. And so really where we're going to be honing in on a lot of this journey is going to be in the sustainability UFC. So that's where we're going to try to focus a lot of our energy towards and provide some crosswalks where we come to the other criteria. So we'll begin our journey here with the lifecycle cost analysis. Whenever I get into a UFC, I always like to start with how it applies. I recommend, when you get into those, there's the applicability section. And so I always recommend starting there. That's going to be section 1-4 with this UFC. And there's going to be table 1-1 that talks about it. And we're going to see that for chapter 1, which is the LCCA chapter. It's going to apply for all design and construction activity. And then as well as assessments of existing buildings greater than 10,000 square feet, as well as there's an Appendix A that states all buildings that meet a statutory threshold. And then there's a footer calling out that threshold is 250K. And so there's quite a bit more there with it. Just say, first part of, the LCCAs that you're going to apply for your project is determining how you apply from the UFC. That's hopefully pretty straightforward. I'll say I've put highlights in the presentation. So I have some highlights sprinkled throughout. My disclaimer is, these are my interpretations of what's key from the policy. And the best way for people to know, what's important in the policy is for them to read it themselves. So, take the highlights here. Also strongly recommend, as you're doing design and other things that you read the policy. So summarizing a couple key points from section 1 here, section 1-6, we can see that LCCAs are required for the following: systems contributing to the energy footprint, renewable energy generating systems, when a life cycle cost effectiveness is a reason for documenting compliance with UFC 12002. And then you have option to use an LCCA to evaluate multiple options to support the project team's decisions. So a little further down in that section, not on the slide here, section 1-6.1, you're going to be using the BLCC program to document your LCCAs. And we're going to be using ASHRAE 90.1 baseline, and we're going to achieve 30% energy savings. Further down in the criteria, another highlight would be the whole building analysis. That's from section 1-6.2. And we'll talk about more on this subject a little later, but we're going to be studying a 40-year period with that. And then in section 1-6.3, it talks about LCCAs for individual components or systems. It talks about acceptable alternatives must not degrade the overall building performance. And then a key highlight out of that section is alternatives must be sound technical alternatives that are user comfort compatible, reliable, locally serviceable, user friendly, ensure safety, and at a minimum are neutral with regard to occupant productivity and design aesthetics. So a lot of emphasis on energy savings. However, need to balance some of that with those parameters that were listed there. We still need it to be reliable. We still need the occupants to be comfortable, and things of that nature. So another highlight from the UFC is Appendix A, which is the Energy Optimization and LCCA Process Integration Appendix. So obviously, since it has LCCA in the title, it would apply to us. Some highlights here are that we are going to perform our LCCA during parametric design process up to 35% design or earlier. We're going to identify our alternatives. We're going to use 3 alternatives. Army says that we're going to select the alternative that provides the highest energy efficiency while remaining life cycle cost effective. Chosen alternative justification: if we fail to meet 30% energy savings below the baseline, we're going to provide an explanation in our design analysis. We're going to balance increases in energy efficiency against our O&M and initial cost. So, energy efficiency is going to be at the forefront, but we're still going to maintain that against our operations and maintenance, as well as making sure that we can afford it initially. For the building envelope, we're going to, for existing buildings, the baseline, we're going to use the U factors from ASHRAE 90.1. And we're going to give preference to durable features. And then when we're using LED lighting, an LCCA is not required. So those are a couple of the highlights from Appendix A. Continue it down here as well. Installation preference. Installation preference doesn't supersede policies or this UFC without approved exemption in accordance. So it's always a great idea to have your installations buy off on the systems that you're going forward. Their buy off will not override for this per this UFC. Funding of features and systems. Items listed in the DD 1391 are required to be provided, and an LCCA is not required. This assumes LCCAs were performed when the items were included on the DD 1391. If not providing an LCCA, then the statement in the DA is required. So strongly recommend, when you do LCCAs, when you don't do LCCAs, that you document those in your design analysis, really showing design progression. Here's the systems we analyzed, here's things we weighed and considered, and here's the direction the design team made. Energy modeling. Here we see that we're going to complete the LCCA no later than parametric design phase, so between 5 and 35%. Any significant changes to the project scope beyond the initial design that impact energy savings or project cost require an updated LCCA and energy model. LCCA documentation in the DA and available for third-party review. So we're gonna put our LCCAs in our DA, and they should have the content level that they can be third-party reviewed. So hopefully this will help dispel the Bigfoot myths. If things start getting into the DAs, as far as people being able to find them, and then jumping into design build projects. LCCAs are going to be prepared during the development of the solicitation package or RFP. The systems and features from the LCCA are incorporated as requirements in the design build RFP. The design build selection criteria requires deviations provided by the offerer to increase energy efficiency, that they're supported by energy optimization and LCCAs, and decreases in energy efficiency aren't acceptable. So several key highlights from the appendices of the UFC. Like I said, wanted to put that in there. I know that's a lot of content covered really quickly. Went ahead and wrote it on the slide so that way there's quick reference. The sections are in parentheses next to the title. to help the, recall a little easier if you're thumbing through those slides. So on the policy, jumping down to the ER. So we didn't stop on the STD policy here. It does have LCCA statements in there. A lot of the statements align with implementing things that are listed in the UFC 1202 and the ER. So very much could add content there. Going to kind of stay in the UFC, ER, and ECB realm because a lot of those statements are executing what are requirements from the STD policy. So I'll highlight the STD items as we come across them. But that's kind of the order that we're going in here. So we'll jump into the ER. So once again, looking at how it applies, the ER applies all projects with USACE as the design and construction agent that are greater than 5,000 square feet and cost over $3 million. The UFC 1202 was updated and the requirements are 10,000. I believe the ER is going to get updated to match that as well and going towards the 10,000 for that square footage threshold. And then jumping into energy modeling, it requires an 8,760 hour simulation. This is somewhat of a yardstick for your energy model. So it's usually those that do it know it as a full year. So if you've done modeling for LEED or others, it's pretty common, but it requires a software that can take that level of analysis. An energy model is not a great predictor of the actual energy consumption after occupancy. So we went ahead and listed that in there of, very much like your gas mileage on your car, the environment and the way that it's driven will greatly impact how the results that you see. So not using that against it, but using these as a tool for making decisions when we're very early in the design process. And so then jumping into the LCCA section, LCCAs are required whether your project is meeting, exceeding, or failing to meet the energy metrics. So essentially documenting your LCCA, even if you're exceeding the requirements, if you're just meeting them, and I would say especially if you're falling below the metric, is having that support and putting that in your design analysis. Another one is when we do the analysis, we're going to use 3 alternatives. And then there's some statements in the ER about using good engineering judgment, where it is clear that the cost of the alternative exceeds the savings. Do not perform the analysis, rather use judgment and experience to select cost-effective features. Strongly recommend supporting your statements and including files with that statement to document that, where if you use engineering judgment, kind of explaining how and why in the project files. Document in your design analysis any systems and features considered but removed. So it's a good idea to go ahead and just list, here's systems and equipment that we considered that may have not been analyzed, but were at least considered to show that the design thought process. And where similar performance is achieved by alternatives, select the most economical. So here we have an economical statement. The UFC for Army and the STD policy are going to look for highest energy savings. So once again, this might be an area that as the ER gets updated, falls in line. It says highest energy efficiency rather than most economical. Centers with standardization, standard designs that have an LCCA do not require an LCCA. Major changes to the standard require an LCCA. So good motivation to not go in there and mess with the standard. is if you have an LCCA. Jumping over to our ECB 2020-8. So there was a sim note. Headquarters Army reviewed several USACE projects and found that they lacked compliance with the ASA STD policy. That was kind of the foundation of the sim note. It applies, so applicability, recommend checking it. It's much like the UFC and the ER. So it lines up with those. So, and then it talks about steps for a life cycle cost-effective design. So there's an attachment, which I'll show on the next slide, performing the LCCAs at code 2, and having them completed before the 35% design. Once again, it's highlighting 3 alternatives. When selecting the alternatives, we're going to give a preference to features and systems with lower complexity and maintenance burden. So kind of see the balance here between energy efficiency, economics, and here we have lower complexity and maintenance burden. It had a section for quality assurance. So getting your district subject matter expert to review and approve the alternatives, and including a signed statement that the LCCAs have been reviewed. And then it had some accountability for the technical lead to be responsible for ensuring these LCCAs were performed and documented. And it has design build statements in there about performing the LCCA during the RFP development. This is the appendix that was discussed. This is kind of like a roadmap for how to perform a whole building LCCA. Real high level is checking your passive systems first, and then going to your active systems, and then finally your renewables. So building envelope, your HVAC, and then finally your renewables. It talks about solar energy. However, with the renewables, there's other technologies. There's wind, waste heat recovery, biomass, cogeneration, and things like that. So there's quite a bit that can go into it. Recommend as you're setting yourself up for performing the whole building out LCCA that you take a look at this flow chart. It breaks it down into pretty digestible chunks of how you can go about analyzing a whole building. And so to summarize from the 3 policies that were listed, I put together a little crosswalk here. A lot of y'all have probably kind of pieced together several of the common denominators that you heard listed throughout, but just try to kind of emphasize a couple of the points that are covered throughout all 3 of them. We're going to document our LCCAs and our design analysis. We recommend providing comprehensive summaries and providing documentation to the level that a third-party reviewer or like an audit or review team could duplicate the results. So not just, one page that says LCCA was done. We're going to actually give some detail that people could go back and look at the breadcrumbs and follow the same path to get to the conclusion. We're going to perform a whole building LCCA. It's going to include 3 alternatives. It's going to be studied over a 40-year period. Energy and water consuming systems are an LCCA is required. The next slide, I have a list of some of the LCCAs that are required out of the policy. We're going to use 90.1 as our baseline and benchmark. We're going to use the BLCC tool for performing the analysis. We're going to perform our LCCA at parametric design between 5 and 35% design. We're going to balance our energy efficiency with our operations and maintenance. 1391 items don't require an LCCA. And design build LCCAs are going to be performed during the RFP development. So once again, kind of a crosswalk between the three criterias for some highlights that are consistent throughout. So wanted to provide, this is a slide, and the data on the slide is from February of 2020. But what LCCAs are required? That's as a mechanical chief, I've gotten that question several times of what LCCAs do I have to have on my project? So try to spell it out here. Recommend, when you're at the project planning budgeting phase, to ask, if you're looking at your LCCA and you're looking at your project budget, what LCCAs were budgeted. That's a pretty good way of figuring out what LCCAs are going to be included. Something like this could somewhat be an a la carte menu, depending on the solutions, and used as a quality assurance tool, something like that. So once again, this is circa 2020, so I don't believe it's been overcome by events yet. However, try to put the citations next to them so that way you can have them as criteria continuously evolves. Some of these new ones might be added, others might drop out. So to discuss some tools of the trade, those that are familiar with doing LCCAs, this will likely look pretty familiar. Energy modeling, so that's software that is going to be used to perform LCCAs. A lot of our analysis are going to require it for a whole building, for your energy consuming systems, your HVAC systems. Typically, you're going to need a whole energy model to be able to get the results out of there, so that way you can plug them into BLCC 5 for your energy. A lot of times, this falls on your mechanical engineer. I'd say they typically get the burden of documenting these LCCAs because a lot of the data is reliant on your energy models. However, there are quite a few third-party tools that can be helpful. If you're doing water analysis, using some of the tools that LEED has for determining your proposed water versus your baseline. There's several really good tools out there for solar and renewables. So some of those. There's a lot of different tools. With your whole building, you're likely going to be reliant on your energy model, and so whoever's performing that LCCA is going to be probably hand in hand with whoever's performing your energy model. The criteria list that we're going to use BLCC as the allowable program for performing the economic analysis. So that makes that pretty easy to know which tool to use for doing the economics. Is you're going to use BLCC. And then cost data. So it can be really difficult to determine your cost data on things. So there's a couple of sources here. Traces, RS means, you can reach out to equipment vendors and reps. But it can vary quite a bit. So that can be one of the tougher things, is getting your cost for your systems out and finding a source that you can document and that you can rely on. An example is if you give a vendor a call and you try to ask for price, I haven't had great success at people being real forthcoming with how much something's going to cost, especially in the design and planning phase. You might get a ballpark range, but getting real cost from some of those sources can be rather difficult. And then maintenance costs and salvage data, that once again, that can almost be more difficult to get than your actual new construction cost data. Is finding reliable sources for how much to assume in your analysis for maintenance, and then what to assume that at the end of the useful life when this equipment is taken down or that something is demoed, the value that you're going to get from salvage for that. Another one is your equipment life. This one's a little bit easier as far as being able to document. ASHRAE has a table here, which is really good for kind of average years of equipment life that can be useful. And put the link in the slide. I believe you can also find it in the ASHRAE handbooks as far as trying to document your assumptions for how long a piece of equipment will last. So jumping into some real world examples, the ER calls for us to do LCCAs and to be documented to a level of detail sufficient for a third party to be able to duplicate the results. So if you want to kind of know how detailed should your LCCA be, it should be detailed enough that someone that hasn't seen it could come in and reasonably duplicate your LCCA from what you provided. The requirements for documentation, a narrative, a schematic of the systems, support calculations, cost data, and assumptions. So things that make up a complete analysis, is a written narrative describing, what was studied, what was assumed, where there might be some uncertainty or risk in the analysis. If you have, like an HVAC system, it's helpful to have a schematic of your system sometimes, a one line. Supporting calculations, these results from your energy model, or, if you use a third-party tool, or you used a spreadsheet, including your support calculations, listing your cost data, and then really recommend listing your assumptions. We kind of talked about several of the pieces that make up a LCCA, and there's a lot of things that can be assumed from those. So just kind of a ballpark, what I'm used to seeing from kind of a USACE LCCA is typically around 10 pages, give or take, depending on what you're doing. Obviously, if you have quite a bit of support calculations from an energy model or something that won't fully be the case. I'll say typically what I see from AEs is like, 2 to 5 pages. But, once again, depending on how much analysis people put in their appendices. So to give y'all some real, tracks, photos of Bigfoot tracks in the mud. However, here's a sample, narrative from a whole building LCCA that was developed for a design build RFP. Once again, just trying to show, kind of the level of content. This will vary significantly depending on your designer, depending on your building, and things like that. But recommends, defining the purpose of what this is doing, discussing the system and the features that you're going to analyze, listing your assumptions, and then with this one, we actually broke out the summary of results per kind of type. So we summarized our HVAC, we summarized our envelope, and we summarized our renewables, and then there was an overall whole building summary. So the previous was the HVAC. Here we see the envelope side of things, and then below that there's the solar thermal or some of the renewable. And then overall summary of results, and then this one had quite a few appendices. We included all of our BLCC reports. We included our cost data. We included the individual BLCCs from the items from the envelope and the HVAC and the solar, and then we used Red Screen to help as a third-party tool for our solar. And so another example would be an HVAC LCCA. So this would be going in line with, an LCCA to document your energy consuming systems. This one here, had quite a bit of time to do the LCCA, so we put in quite a few alternatives. I think there was 8. And so doing that, list our assumptions, list our summary of results. So once again, just kind of typical narrative format. We included some system schematics to kind of help kind of convey, the intent. I'll say, your LCCAs are being performed at the 5 to 35% level. So, to be fair to your HVAC, person that's doing the analysis, you wouldn't expect to see 100% design, listed in your calculations here. It's a very schematic parametric design at this point. So your analysis and your kind of assumption of your systems is probably going to match of, your 5 to 35% design. So your LCCA is going to be, probably 5 to 35% level of design complete. So once again, that's part of why you see kind of line diagrams with these things rather than, a complete, floor plan and some of these, deeper analysis. So here's an example of summary reports from DLCC. Here we have on the left a summary showing which one had the lowest life cycle cost. And then on the right, there was a similar analysis where we were doing a sensitivity study. So we increased the utility rate by 30% to see if the results would vary. So once again, getting into the criteria, it's a good idea to perform a sensitivity analysis on some of your key data parameters, utility rates, equipment cost, O&M cost, and see if that will drastically change your results. An example of some support calculations. Here we had a report from Trace, the energy modeling software, and then on the right side was just some general, I believe this was a condenser heat recovery, so trying to document the assumptions that went into sizing, the demand or the load for the heat recovery machine. So once again, trying to leave enough information that, a third-party entity could come in and back out, the results to have performed their own LCCA. An example of cost data. So this is a typical kind of Excel spreadsheet that we use. Strongly recommend citing your source with your cost data because it will be hard to find it later. So, if we're going to leave a trail for others to be able to follow, citing your source is really good. Once again, we're doing this at 35% concept. So, our cost might be parametric. We're not going to have, necessarily a summary of every valve, because the system may not even be laid out. It may, almost be a cost per square foot. Typically you can pick up the large pieces of equipment and you have a ballpark capacity, if you're doing HVAC. So once again, don't hold your LCCA preparer to a higher standard than where you're actually at in your design. You should be able to get enough cost that you can kind of estimate your system. There is a lot of data out there. The ARS means books have some really good data on your system types. And so once again, breaking out the cost, strongly recommend putting down your assumptions. You can see there's a table there or a column for years of life. If you're doing a 40-year study and your equipment's only going to last 20 years, you are going to have a replacement, and that needs to be showing in there to get a complete 40-year study. As well as, the replacement cost, assuming, preventive maintenance, as well as residual or your salvage value. So things that go into making up a cost, trying to get all that information into a report. And so some reminders, we're going to perform our LCCAs. They're being performed at less than 35% design level. they're concepts. They're not detailed design. They're definitely not shop drawing level. Typically, our project cost at 35% is parametric. So the LCCA costing might look parametric as well. Once again, where we can get more detailed, recommend it, but it is, it can be difficult finding some of this data with a very concept design. Utility rates. So this can vary quite a bit as well. We have some installations that have really low utility rates. I actually had some on projects where trying to get it certified by LEED, they thought we had an error on how low our utility rates were because it was the rate provided from the installation. And they wouldn't accept it because it was so much lower than EIA.gov. Kind of realized to stop fighting them when we remembered LEED is based on energy credit savings, and going to a higher cost can benefit you, and you might actually get higher credits. But anyway, so utility rates will vary. EIA.gov is a great resource for state averages. If you get into a similar situation where USGBC or LEED doesn't believe your energy rates, it's a great way to document them. And then incomplete and uncertain information. So we listed quite a few things. There can be quite a bit of uncertainty. Once again, recommends documenting our assumptions. Some of the things that are going to contribute to some of this uncertainty are going to be, the initial investment. If the cost for the systems are wildly inaccurate, then it might throw off your analysis. If your O&M costs that you assume aren't near the mark, then that can very well change the results. If your modeled savings, if those aren't accurate, then that can offset your analysis, kind of like in miles per gallon. Once again, your salvage value, that can be a really hard one to predict. What something's going to be worth when you're taking a air handling unit off of a roof. Predicting the salvage value, that can add some uncertainty in there. And then service life, how long is this going to last? Had an example where, we had a VRF system that was installed, and 4 years later it was removed because it was the operations and maintenance couldn't maintain up with it. And, obviously it was selected for, I think they had actually used a 25-year life. But there was no way to, really know that, in less than 5 years it was going to be taken out because of, user preference. Things like that, that obviously would contribute to the uncertainty. And then once again, kind of a plug for doing the sensitivity analysis. So if your analysis is sensitive to one variable, kind of knowing that and documenting it, utility rates, and, first cost, things of that nature. So once again, just kind of summary recap. What we discussed, what is an LCCA? Went through quite a bit of the current policy, a real brief tool of the trade, and then try to provide some real world examples so that way you can say that you have seen Bigfoot as well. So I believe there's a lot of questions. The way I have my screen set up, I can't actually see them all. So I'm going to try to exit out and stop sharing to see if I can get to some of the questions, and we'll see how many we can get through. Ned, do you happen to have kind of a rolling list, or do you just want me to kind of scan?
Yeah, let me switch over to, hopefully that's the right one. That is not the right one, sorry. I just messed up my own list. Sorry about that, everyone.
So I think the first one I'm seeing is from Tyler, and the question is, are all new construction projects required or that are subject to UFC 102 required to go through LCCA process regardless of size of the project? I would say yes, if we're going to use UFC 102. I would also say, if I would check your ER, because we list the square footage there as well as the cost threshold, but kind of not knowing the circumstances, I would say probably going to be required to document your LCCAs if you're going for new construction under UFC. There's a comment here from Dan Edwards on Cost Lab. Is that a resource, another kind of costing resource for finding cost data?
Yeah, it used to be called Whitestone, but now CBRE owns it, and you can do, if you want to pay the money for it, you can get like fancier versions of it. But the thing that we have a license for just gives you what crews would be involved, if it rental equipment, we're doing and also materials cost for routine maintenance, replacement, and so like say a chiller might have a replacement at year 20, a major overhaul at year 15, and your routine maintenance costs, and it has all that data in there. Over.
Great, thank you. Thanks for the recommendation.
Can you see the text, Kirk, of the questions on your screen?
Yes, yeah.
And I'll scroll down. You can tell me how much to scroll down. I'll let you handle the questions.
Okay, yeah, I see another one from, is it Marilyn? What type of items or information should we gather from the customer to initiate the LCCA? A great point. Usually start with your utility rates. If you can get O&M cost and frequencies from them, that's great. I haven't had great success with that. Those two items, as well as kind of preferences for the systems that are going to be analyzed. Just kind of off the top of my head, that those are the items that I could think of, that might be good kind of direct questions as you're kicking the project off. Next one was shelf life. How long is an LCCA good for? How often does it need to be performed?
And you may want to look at the next question also, Kirk. They kind of go together.
Okay. How do you recommend handling the LCCA process for projects that will sit on the shelf for several years? Should the LCCA be complete before shelved, or if it's pulled off the shelf, or both? I would say most projects aren't shelved, at the 5 to 35% level. So, kind of reading this, my recommendation would be performing your LCCAs in the time frame, of the 5 to 35, like we're supposed to. And then it can be with the project. And then most projects that are shelved, that I've experienced, we shelve them, closer to final, corrected final, something like that. And so having those there, as far as reperforming the analysis, my understanding is, the LCCAs are there to justify the design decisions, and you likely aren't going to go back real far on a project and kind of reconsider your design decisions. That being said, there is statements in the criteria that if you're going to make significant changes to your energy usage or your building function, that you are supposed to go back and update those LCCAs. So it kind of might depend on what the project looks like when it gets pulled off the shelf. Is if you're going to do a pretty heavy redesign, then yeah, you might want to look at your LCCA again. But that's probably not going to be the most clearly defined from your criteria. How long does it take to put together an LCCA? It very much depends on who's doing it, how familiar they are with it, and which LCCA they're doing. So off the cuff, I'll say, a lot of the smaller ones we can get done relatively quickly because we have good processes. So like solar, thermal, that LCCA requirement's been around for a long time. So my team can usually crank those out in a day or less because we have templates and tools and we're familiar with it. Whole building LCCA, the hard thing with that is usually you have to model the whole building. So yes, a number of weeks, primarily for modeling. And then once we actually get the data, inputting it into VLCC is pretty fast. Cost data, obtaining that can take longer. So yeah, I'd say, a month for modeling and whole building LCCA might not be outrageous.
Next one's not a question, but thank you to Greg for some updated information.
Okay, yeah.
I'll scroll down a little bit. And I think we've already answered that one just a moment ago, unless you want to hit it again.
Yeah, I see the one about, emailing examples. Yeah, if you want to email me, I'm pretty open about sharing some of our examples. That's part of the intent behind the slide. It won't do you as much good, Mac, as you're probably thinking, because every project is different. Every analysis is going to be different. So really kind of highlighting, here's the pieces that need to be in there. So, if you're reviewing or if you're planning on performing, you kind of know what pieces are required. But yeah, I don't mind sharing examples. It's just at the end of the day, the requirement for a narrative is going to be there and things like that.
Sure. Thank you.
Yeah, I see Don's question about energy costs. It can be really tough. I like to use EIA.gov primarily because it's documentable. Like I said, a lot of the installations in my district, we get really low utility rates. Half of what EIA.gov is showing. So I kind of like to use EIA.gov because I can always point back and say, here's where I got my source from. As far as escalation rates and things like that, yeah, it's a snapshot in time. And once again, just kind of doing the best you can to document your assumptions. So yeah, the next one about which disciplines or team members are key for developing LCCA. That's a great point. We actually cover this quite a bit in the prospect course. There's, the really good answer is the whole team. I'm sure the mechanicals everywhere would love that answer. Architect, if we're going to study the envelope, getting their input is really key. Electrical, your mechanical, and things of that nature. If you have a separate sustainability point, having that point of contact involved. Yeah, no, it looks like Dan's answered that below. So yeah, cost engineering, a lot of them won't return my phone calls because of how many LCCAs I've done. So keep that resource if they'll answer your call.
If I could add something to that, Kirk, on your slide 11-15, you did mention that the technical lead is responsible to make sure that everybody is included that should be included in the LCCA. One thing,
Yes, great point. Yeah.
some of our districts that I've worked with have a strong technical lead system, others don't. And the second thing, having academically trained and worked for many years as a structural engineer, quite often they are left out, especially when it comes to thermal bridging and aspects. Of course, that's on the energy modeling, but it does impact other aspects and things that they do having to do with interfering with light and so forth. And so that impacts the LCCA in many ways. Also, they can add costs, first costs, but like using stainless steel instead of ferrous steel in some areas that are exposed to the outside, and it impacts the energy, which impacts the life cycle cost. So just thought I'd throw in a plug for structural engineers to be involved when it's appropriate. Over.
Sounds good. Yeah. Get as much of an integrated design team as you can get, you know, and that's something that's pushed with the prospect course is talking, you know, getting the key members involved early when the decision making is occurring. And then I think the last one was typically is the LCCA performed at 35, updated at 65 and 95. I'll say inherently no. With my group, we kind of document and we make our decisions and we move forward, but we are also trying not to have, you know, major energy changes or criteria changes, you know, kind of triggering that ER requirement for updating them. Is hopefully we've done a really good job, you know, kind of planning out our concept that we're not going to have a drastic change further down the road, and we're doing more just kind of you know, design detailing at those phases. So with that, I think we're at the time, and so I appreciate everyone calling in, and y'all have a good day.
Kirk?
Thank you, sir. It was very good.
Kirk, you have time for a real quick follow-up, or should I call you after this?
This is Ned. If Kirk, if you're still on, it's all right with me. I'll keep the recording going, and we'll hang on for another minute if you'd like.
Okay. Yeah. I think I heard someone asking me to stay on.
Yes.
Dan Edwards with Philly, and not to cause myself more trouble, but going back to Tyler's original question regarding the, you know, if the project is shelved for a while, like, in fact, I was just looking at the 1-200-01, the building code, and it says if there's a delay on a project, at least 18 months, whether it was intentional or unintentional, that you have to go back and look through update the criteria. And so in that sense, I mean, is there, like, say we do our LCCA now based on what's enforced, the 90.1 2013, and by the time the job comes off the shelf, 2019 has become the law of the land. Do we have to go back and revisit it? Or, I mean, hopefully policymakers will grandfather the things at that time, but based on the way it's written, it would seem like you would actually have to go back and redo your analysis.
Yeah, I can see that argument. I guess I go back to kind of, you know, if the design decisions have been made and we're not going to, you know, if it's truly just like a code check kind of, you know, we're not going to go add another floor to the building or something, you know, drastic. You know, my intent would be we documented the decisions, you know, and then we, you know, those are what we used at the time. You know, policymakers might see that different. You know, with how they read some of that.
Right. I wasn't saying like what would be the common sense thing to do. I'm saying like, what are they going to make us do?
Yeah, and I'm not going to answer for that one. Yeah.
right.
Yeah.
That was just it. Because, yeah, you like you look at it, it's like, based on the way it's written, you might have
Well,
to.
you're working on the ER, for LCCA edits. So if you want to add something in there that says we don't have to, I won't argue with you.
Well, that's gonna be the new ER. You don't have to do this anymore. And Trisha Donahue will hunt me down. And no, anyway. But all right, thanks. I was just curious.
Yeah, well, like I said, that's Kirk's interpretation, and that may not get you really far. So.
All right, thanks. That's all.
Yeah, no problem. Yeah, have a good day.
Too.
Kirk, I'm going to stop the recording now. Thank you, everybody.
Thank you.